All right. Thank you. Thanks to everybody for showing up. Thanks to Alex for organizing this and the AWS team. This is definitely the swankiest area that I've done a meetup. I wasn't expecting this. So I'm just going to kick us off. I get to introduce a lot of Rich's hard work here. But just by a quick show of hands, who here has heard of Casper before? Okay, actually, it's probably easier to say who has not heard of Casper before. Okay, a few. Okay, so this is for you guys, and then I'll give you a lot of context on the stuff that Rich is about to talk about. So Casper is a company that started in 2014 with the ambition to sort of reinvent the way people sleep at night on mattresses and the way that they purchase mattresses. If you bought a mattress pre-2014, you probably had to walk into a really big mattress supplier, and there's like 800 options, and you don't know the difference between all of them, and you probably had problems with your mattress, right? Back pain or whatever. And so Casper came about, sort of revolutionized that whole purchasing experience and the mattresses that we slept on. In a few short years, Casper sort of disrupted the mattress industry. And it has since sort of pivoted more to being a sleep company in total. So, for us, the long term was never just about mattresses. Now we want to help the world understand what the first sleep company will do. We have multiple mattresses now. We have bedding products. One of the things that I'm really excited about is our sort of IoT or tech products that we're going to be selling. We just launched our first one called the Casper Glow, which is a smart light that sits on your nightstand. I hesitate to call it a smart light because it's so much cooler than that. I have a ton of smart lights in my house. This one is by far my favorite. You can be high tech with it, you can be low tech with it, and I think that sort of combination really sets it apart. So, check it out. In terms of the stuff that Rich is going to talk about, what I wanted to give everybody a sense of is everything that the Casper tech team does. You might be saying, wow, a mattress company needs a tech team. And I thought that exact same question when somebody asked me if I wanted to work at Casper. So I just want to give you that context so you know why we have an SRE team and what they're doing. So our tech team handles pretty much all of the technology for the company. It didn't start out that way when I began, but just to give you like a sampling. So our business started as e-commerce business, and so we manage our front end and our back end of the e-commerce stack. Shortly after e-commerce, we started doing our own retail stores. So to date, we have about 20 retail stores. 2 of them are in New York City. How many of you guys have been to a Casper retail store? Okay, cool. This is great. So it's a really cool experience. It's very different than any other mattress buying experience I would bet that you've had before. We deploy custom technology into those retail stores. So we have a POS device that we've written in-house. And then, we have to get all of those mattresses into those stores, and we have to get the mattresses into people's hands. So we have an application that does order fulfillment and logistics, so it integrates with our warehouse partners and our manufacturers. It turns out that takes a lot of code. Before I started at Casper, I would always get so mad if my package was 1 or 2 days late, and now I'm like, don't worry about it. It's fine if it's a week late, because it's really, really hard to get packages to people's doors. We have a team that manages our data warehouse internally, which has a lot of data in it, needs a lot of support. We have a team that, God, I'm probably missing a few teams. What are our other teams that I'm missing off the top of my head? We have a retail team, a site experience team that does the whole front end. We have the connected software team that I just mentioned, which is really exciting because for the first time, the software team gets to build a product. So we have a Casper app in the iOS store, iOS App Store, and the Android Play, Google Play Store that you can download to control the Casper Glow. So there's a lot of technology behind the scenes at Casper, and so we wanted to talk about how you keep all of that afloat. So without further ado, I will stop taking Rich's time and let you get into the talk. Thank you, everybody.
Thanks, Kyle. So Kyle kind of just went over our engineering org, but just to reiterate, so currently we're at about 40 engineers. We have 11 pods organized into 3 domains: site experience, operational, and ops, which is corp IT, us, and tech ops, and data engineering. We're spread across 3 offices, Berlin, New York, San Francisco, and we all support this with a team of 3 SREs. So what is DevOps? Do you want me to read this? I'll read it, all right. So DevOps is a combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity, evolving and improving product at a faster pace than organizations using traditional software development and infrastructure management processes. This speed enables organizations to better serve their customers and compete more effectively in the market. Source of that is AWS, link at the bottom. So what does that mean? At Casper, we don't really use the word DevOps, but we've kind of distilled all that words into a couple of major points. All our teams own their applications. You deploy it, you own it. Everybody's on call, and teams are responsible for identifying their operational needs. They don't need to own it, but they need to know what they don't know. Common problems require common solutions. Don't reinvent the wheel. Just buy if you can, and just build your glue, unless it's in support of the business. And operations is a first-class citizen. We do technical design processes that last a couple weeks, and operations, SREs, are involved in every step of the way. And we do quarterly plannings where teams should be calling out any needs that they need in terms of infra, help on operations, things like that. So I said what everybody else does in terms of ops. What does tech ops do? So we own and provide oversight for all our application infrastructure, pretty much AWS. We own and build and maintain our CI/CD pipelines so that engineers can build and deploy with confidence. They can deploy anytime. Everything is done through Slack, ChatOps, shout out. And we work with all our application engineers and our teams to kind of ensure best practices are being followed with respect to security, monitoring, and logging, basically observability. And to enable that, we provide tools and services for engineers to interact with the infrastructure. So, promised that this talk was DevOps at scale, but I want to talk about what our problem is not first. Application performance is important, but it is not a challenge. Auto-scaling groups, extensive use of caching, all that solves all our current application scaling needs. But scaling our team and our systems to support the rest of the engineering org and the business while maintaining, operational excellence is. So I'm going to kind of go over 3 kind of major milestones that we hit in the course of the last 2 to 3 years. Little context, I started at Casper in 2017 as an SRE. Some of these projects were in flight. Some of these were kind of wrapping up, so I am taking credit for some of the work of other engineers. So I kind of want to talk about how we consolidated all our services in AWS first. So in the beginning, we had 2 platforms. We had Heroku and we had AWS. Heroku was where pretty much all our engineers worked. Casper.com was hosted on Heroku. All the supporting backend applications, fulfillment, email, all that. Click of a button, you get Redis, Memcache, Postgres. Click another button, you get logging, monitoring, and pretty much whatever is available in the Heroku marketplace. So that was super easy for engineers to use. We had a team of maybe like 2 or 3 engineers that worked on the code, and it was pretty much one-click deploys. Then we had AWS. AWS is where we initially just started with pretty much S3 for data storage. We had a Redshift cluster for our data warehouse, and some of our ERP and financial systems were hosted there. So at some point, we wanted to combine the 2. And why, right? Like everything's work. Engineers love git push, Heroku deploy, you're done. But Heroku needs to talk to AWS. We did not have control of our network infrastructure. Things were kind of going a little bit out of control where every team could just add login trees, New Relic, whatever. We were supporting like 3 or 4 different copies of the same service, but from a different vendor. So how do we do the migration? These were the three main goals that we had in mind, right? So we had to continue supporting the current deployment process, Heroku, but also build into our CI pipeline the ability to build and deploy applications to AWS. We want zero unplanned downtime. I'll get to that later. And zero disruption to engineers. We don't want the customers to have outages, but we also don't want to slow down our engineers. So we kind of hit the drawing board, and this is kind of the major steps that we kind of iterated through. We use Fastly at the edge for our CDN. Sorry, Amazon. So basically with Fastly is basically built on Varnish. VCL is pretty straightforward to use. We had a couple engineers that knew about it, and it was simple-ish to support what we wanted to do, which was route traffic to multiple backends. This means we would continue routing traffic to Heroku while building our AWS platform. In AWS, we decided to follow the golden image methodology. So basically, we bake AMIs fully configured. We use Packer and Ansible to accomplish this. And we use Terraform to pretty much do everything else. And other than configuring infrastructure, VPC, subnet, security groups, IAM, DNS records, RDS, Elasticache, et cetera, et cetera, et cetera. We also use Terraform to drive our deployments. So this is basically the new unit that we came up with for deploying any application. We do have caching in the name of CloudFront. ALBs, autoscaling groups, multi-AZ pointed to RDS, Elasticache, and Memcache. These are all configurable within the module depending on what you need, but this is basically the full package for any of our current applications. Some of them are web-facing, so you need everything. Some of them don't need ingress from the public internet, et cetera, and all that is kind of toggleable. So we did this over a course of maybe about a year, and while we were going through this process, we were running our Casper.com, our main storefront application, simultaneously in AWS and Heroku. We did wind up having to take one planned maintenance window because we could not find a viable hot migration for Heroku Postgres. Our build and deploy process was kept mostly intact. Basically, because we use ChatOps for everything, we hid the complexity there. The commands were the same, but we were able to shift our logic and kind of hide that complexity from engineers who really don't care where we're deploying applications for the most part, right? But we did introduce a little bit of a bottleneck. The SRE team knows Ansible and Terraform pretty well, but not everybody does. So occasionally, if a package version or dependency changes, we would have to kind of write the code first, and then, while they're waiting for us to kind of finish up, they can't really deploy. And we did inherit a little bit of tech debt that we still kind of are slowly chipping away at. And like I mentioned, basically the main issue that we had was because we allow teams to pretty much configure their own application in Heroku, we did have multiple services that we need to eventually slowly unify into basically one monitoring service, one logging service, one stack trace collection service, et cetera. So the second project, which was happening sort of in parallel, was decoupling our front-end application from our Rails application. So again, when we started, we had a Rails app. All the front-end code lived in there. It was pretty much vanilla jQuery. A lot of pain points there because deploying front-end changes kind of required deploying the whole application. If you fail tests on the back end, you can't deploy. If you fail tests on the front end, obviously you can't deploy. And basically, you have to run multiple test suites to be able to get a kind of green test to get everything green before you can deploy. And this doesn't really scale when we make so many changes on our front end, on Casper.com, our brand, which we invest a lot in. We have a lot of front end developers that deploy multiple times every day. We cannot couple them to our back end changes, which the development cycle takes usually a little bit longer. So we had our couple front end and back end. Also, operationally, basically, if the app's not available, nothing is, right? Other than whatever is available in the cache. So this was the architecture we came up with for our new front end. Again, we pushed our routing logic out from Rails into Fastly. We built multiple single-page applications for various parts of our website. They're all hosted in S3. And our storefront application effectively becomes an API server for all back-end functions, such as add to cart, promotions, things like that. So in the course of doing this, other than migrating to S3, we had to add a little bit of tooling to our deployment process because we never really had to think about routing logic, right? Everything's in routes RB, you deploy, and you're good to go. We had to build a little bit of, we built a Lambda that would update Fastly with, our basically front-end routes. So afterwards, everybody was pretty happy with the result. Front-end developers can deploy multiple times a day. They're not constrained by the longer development cycles of our backend. Pro tip here, use feature flags on both sides. That way you won't get bitten. And it will be somewhat easier to turn off things rather than having to roll back or wait. And we kind of leveled up our ops organization a little bit. We created a new front-end ops pod, which was created to support the continued evolution of our front-end pipelines. They're doing a lot of really interesting work. They've recently kind of broken out all the build process into lambdas that are triggered in parallel, so we can kind of build all our pages more or less simultaneously in parallel and kind of like deploy in like 2 minutes. So I talked a bit about our application development process and how we sort of evolved to handle the growth of our team and things like that. The last project I kind of wanted to talk about is how we address our growing infrastructure needs. So Casper, we launched currently about 20 retail stores-ish. I believe we want to go to like 50 or 70 within a year or two. So this presents a new dimension to like our infra and our routing. We now have stores located pretty much all over the US that have systems that need to connect to our ERP. Our financial inventory systems are not available on the internet. We have some vendors that we partner with to support some of this infrastructure in other account and VPCs. And the only way that this was working in the beginning was manually configuring devices for VPN, route traffic through our office VPN, maintain whitelist IP addresses for all stores, which doesn't always work. Some of them have dynamic IPs, and that really turns into a bit of a nightmare. So we set out to build a scalable VPN solution, right? I don't know how many people here use VPC peering connections. How many people maintain VPC peering connections of more than, say, 10, 12 VPCs? Do you enjoy it? No. Right, so we currently use VPC peering connections. It was a source of pain. Basically, anytime we had to do any kind of routing, depending on the path that the request took, we would have to call multiple people and kind of get like keep multiple wheels spinning and kind of like, it was a pain. So thankfully, AWS Transit Gateway launched before we needed it. So we decided to take the opportunity to have to do this to kind of roll out Transit Gateway as well. So our corp IT team is familiar with Meraki. We use Meraki in our stores. So it was just like, hey, why don't we just go off the shelf? We use Meraki Auto VPN to automatically provision our stores, internet connections. We plop virtual appliances available from the marketplace in a VPC in our account, and we use AWS Transit Gateway to manage all routing between stores, our accounts and our vendor accounts. So this took literally about a week. It was a really good example of communication and kind of working across different teams. Our corp IT team, pretty much we gave them a new account and they just kind of went running with it. So now we're slowly retiring our VPC peering connections. Some of our vendors are a little hesitant about switching over, but for the majority of our routes, we now have them centralized in one account. And store rollouts are a lot smoother on the network connectivity side. It's part of their runbook. And we literally just add one route and everything's good. So everybody's happy. So now we have this huge infrastructure. What's next? So serverless, we currently run about 400 instances across 3-4 AWS accounts. It's not super large, but it's a bit of a pain. We have a lot of endpoints that are perfectly suitable for serverless framework, right? So one of the things that we've tried to take to heart is kind of advocate serverless when building new services, if possible. And also to sort of set us up from further breaking down our Rails monolith, we've put API Gateway in front of our two main Rails applications to act as proxies to make it easier to switch between our old Rails app and switch to whatever new service gets built to replace it. Containers. So not everything is suitable for serverless, right? You have long-running tasks. Compute, it starts to add up if you're invoking Lambdas a couple million times a month, right? So we've been looking into containerizing our applications. This has two major benefits, from our point of view. Our developers kind of get to unify their local as well as our remote environments. They no longer really need to read a lot of Ansible. Everything's contained in a Docker file. You pull a little bit of secrets when you start your container, and you're good to go. And we're currently kind of evaluating where we are and what the sweet spot is between running everything on ECS or moving to something a little bit more complex like EKS, which is kind of a big decision for us. We're probably going to spend another quarter kind of playing with both before we really make that decision. So I kind of went through a lot of stuff, right? We did projects, we shipped, we helped make things better. But really what I wanted to kind of close on was what we discovered. And really it's like I said, we don't really use the word DevOps, but we built a DevOps culture. So our product managers, engineers, SREs, everybody is aware that there are operational costs to pretty much everything, and it's pretty much ingrained from day one that if you're launching any new features, changing anything, just speak up and let people know, which kind of leads to the second point, is communication. We plan early, we plan often, we do a lot of technical designs, we do technical design reviews, we do reviews of technical design reviews. There's multiple drafts before we even get everybody into a room because that costs money. And basically the goal there is to shorten the feedback loop, prevent surprises, so that you're not throwing something over the wall to your ops team and saying, hey, deploy this, because they will throw it back. And really the last thing is things change. We moved from Heroku to AWS. That doesn't really mean Heroku was a bad decision. We outgrew it. So basically the lesson learned there is always build with the eye towards the next evolution of that system. So, that's it. Thanks for coming out. Questions? Okay.
All right, now we have some questions from the audience.
How did your SRE team come to be? Did it evolve out of the DevOps team, or was it created independently to serve specific needs? Kyle, do you want to take this?
Sure. So when I joined Casper, we weren't big enough to have all these defined teams. We just had software engineers, and they were figuring it out. I was actually just asking Stephen, raise your hand here, another one of our first SREs, how it came about. And I think one of the points that Rich covered has been resonating, as we talk to SREs in the community, is that everybody's on call. It's not just the SREs that are responsible for fixing fires in production. But that was, those kind of conversations are what created what we have now, which is a dedicated SRE team of several. It should be more. I'd like it to be more. But once we decided that we wanted, to specialize and we want people just to focus on infrastructure, which sort of reduces, as a software engineer, the amount of things you have to cram into your head, the amount of things you have to focus on, and then just gives you a really strong partner, right? So you can focus on writing the code. You don't have to focus that much on how it's deployed. And that partnership, I think, has been doing really well at Casper. But that's how it started. That was, exactly 2 years ago almost, when we started the SRE team, and that's how it got started.
Right. I guess the one point I would add is just that once you start moving out of kind of one-click deploy solutions like Heroku, you will find that you will need people with that expertise. If you have developers who have that, great. If not, then you will need to build a team and hire SREs. Question 2, did you prioritize which systems went to DevOps first? For instance, Econ Portal first, and then ERP or any other prioritization criteria? And I think our priority really is dictated by kind of, I want to say need. Basically, for example, I guess we prioritized the storefront application first just because it was the biggest application, and we felt like if we were able to break that down into some units and some reasonable abstractions, it would be relatively easy to move everything else. So that's why we prioritized storefront first for the move. In terms of the front end, like talked before, that one got priority because that is our brand, right? Casper.com reflects who we are, what we believe. And also, we have the most people working on it, deploying it. So, that's where your gains are going to be the most if you DevOpsify it first or second. So what are some common pitfalls Casper avoided in a high-growth environment, and what do you attribute the good decisions to? I think the most common pitfall that we sort of fell into was not really taking a step back and thinking about the build versus buy decision. A lot of our problems are not unique to Casper. We don't have a lot of super complex or unique technical challenges. And so that means you need to make sure that before you build something that you're not kind of reinventing the wheel, right? So I would say the biggest pitfall there and the biggest cost of that is just kind of going back and refactoring and kind of pulling out this code that kind of worked at the time, but it turns out there was a great solution that we could have paid a little bit of money a month and let someone else maintain it. Can you please describe your CI/CD build environment, and have you considered code pipeline? Our CI/CD build environment is basically Travis. All our application teams own their own repos and their Travis jobs. We help out a little bit in terms of setting up the initial containers. Travis drives all our tests, and once they're done, we have deploy hooks and web hooks into a microservice that we built that controls the build and deploy logic that happens in an ECS task in AWS. Ooh, this is a good one. Who in your team is responsible for monitoring the AWS bill? The don't kill me, Kyle, but I don't really look at our bill a lot, which I think tells me that we have not hit that weird inflection point where time is less valuable than the cost that we're paying for AWS. Our bill is not super significant. Obviously, cost is a factor we think about all the time, but if there's a decision between launching faster or being a little bit more inefficient with your utilization, such as, hey, let's just use all scaling groups and AMIs instead of building out this containerization platform so that you can increase your utilization, which is we're getting to now, right, 2 years later. So yeah, I mean, I look at the bill, I would say, unless it's really a problem, favor moving faster. What do you build your front end in? React, vanilla, HTML, CSS? Well, does your front end have their own internal product they own, or do you have a micro front end architecture? Our front end, I believe, is in mostly React. I am not a front end guy, sorry. And since handing off the pipeline to our front end ops team, I'm less familiar with what they use currently. But basically, each team, we currently have 2 separate applications. I believe they're both in React. I know they share libraries. And yeah.
I know a little bit about our front end, not a lot more than Rich, but we are using React, and then for state management, it's Redux. And then the 2 teams that Rich mentioned, one is our shop team, so they do all the marketing content on Casper.com. So they have their own code base that they work in, which is really nice. That's about 10 engineers or so. And then we have another smaller team that we call Checkout, and they have their own code base. That's a single page application. And that is just for, after you clicked add to cart and then you go to checkout on Casper.com, you'll actually, switch front end code bases unknowingly, which is the goal. And then you're all on that application's code base. It's all sort of pre-rendered using a node server, and we drop the HTML files into S3. So it's pretty standard, but also pretty nice because that scales really well.
How did you handle the initial shift politically and technically to centralizing configuration management? I would say there wasn't really a huge political shift. I think a lot of engineers are on board with never having to read a single Ansible playbook. They just want their code to work. Like I said, it's kind of the cost that we introduced when you move away from something like Heroku. So they were more than happy to hand that part off, as long as we don't, slow them down. So I think technically the problem, that's where the problem was. We currently use we use Ansible to build images. Sometimes things will fail, whether it's for an RPM mirror is down, you have random transient communication errors, some random packer timeout issues. That stuff happens. We've kind of just built our CI pipeline to be super noisy about stuff like that, to spit out alerts. The ops team knows that we're the owner of that. We try to react as soon as possible when we see build failures related to AMI, building issues, as an example. And I think we've kind of built enough cred that the random issue doesn't really cause too much friction between the teams.
I'll just add a little bit to that. I think it's a great question. I've been very, very impressed with the team at Casper. We don't have huge battles. I know at some companies I've worked with, it's okay, got this architecture change. These 2 engineers are going to go in and battle the rest of the team because nobody wants to change it. I think generally speaking at Casper, the team is very open-minded, and we all just want to solve the challenges that the business is facing. And the other thing that really, really helps on this process is our technical design process that we sort of do for any large technical decision. So anytime somebody wants to propose that we spin up a new application or change the architecture, we'll go through basically what's a 2-week process. So those engineers will put all their thoughts and all their writing and all their research into a technical design. Depending on the change, that could be a 30-page document, it could be a 7-page document. But that covers every single aspect that you could possibly want to know about with the technical change. And we don't even start on that until there is a product requirements document explaining why we're doing it for the business. So you don't really end up in a situation where you're like, whoa, we're being asked to change our whole infrastructure here, and why? Who wants this? You have all of that laid out before you even start getting into the technical pieces. And like Rich mentioned, there's several stages in that review process. So I'll look at the technical designs. The tech ops teams works really closely with everybody to make sure that the operations concerns are handled, how it'll be deployed, all of that stuff. They work with our security engineer to make sure all the security pieces are done. Downstream data, going into our data warehouse, we'll have that all situated, so that by the time we send that technical design out to the whole team, it's really thought through, and you're not getting sort of like half-baked ideas on changing your infrastructure. And that's been really successful for our team. So so far, any sort of changes has actually been really good at Casper.
If Casper had to be done again, would you start off with Heroku again or use AWS from the jump? This is an interesting question. I'm trying to figure out how I want to answer it. All right, so if this is assuming the same number of engineers going through the same journey, I think Heroku was absolutely the right choice at the time. If you don't have the ops expertise, it's super important to move fast, especially in your growth stage. Now that said, I would say I wish there was someone to at least kind of maintain a little bit of standard across your multiple Heroku applications, so that some of the issues that we encountered could be avoided, right? And no, I think that's it. Yeah, I think you just have to realize that at some point you may need to move off Heroku and just realize you'll have to pay that cost later. But I absolutely think, given Casper's organization at the start, that Heroku was absolutely the best choice. All right, given that Transit Gateway is limited to a single region per deployment, is all of your AWS infra running in a single region? I feel like I've been exposed here. Yes, so our EC2 instances are multi-AZ, but same region. We have replicas set up in other regions for an event of failure. We have S3 replication set up multiple regions in case of failure, but yes, we are currently only in one region.
I just have to give a shout out really quick. John, raise your hand. John used to work with us on the SRA team at Casper. He set up our cross-region failover for S3, because the whole front end of the website is hosted in S3. And I think was it 2017 or 2018 when there was a big S3 outage? And we were just like, God, how is this happening? We just put our whole website into S3. And so John did a lot of the replication is rather easy, but the failover at the edge, he did a lot of work there. So now if there's a regional S3 outage, we're pretty protected for that. So that's amazing.
While shifting infrastructure, how did you bring development along versus the big reveal as you moved forward? I think actually our big reveal happened in the beginning. I think everybody always knew we were moving from Heroku to AWS. We always made sure to give updates during our quarterly planning meetings because it was going to take more than one quarter. So I think really it was mostly the former. Like, we just had to slowly bring developers kind of like on board with the move as we go along. We have an ops CLI that we wrote that is mostly just a wrapper on a lot of common tools, like, for example, like Terraform, Crestash, which we use for secrets management, things like these are all like new concepts in AWS land versus updating something in the Heroku portal. And we just had to like slowly introduce that out into org and tell them, hey, if you want to update a secret, you need to use this tool. and just have a lot of documentation on how to do, how to like deploy to AWS or how to deploy to Heroku. When you say the front-end developers can now develop multiple times a day, do you mean they are developing for the API or they are developing a front-end behind the API? I think a little bit of both. Our front-end team does, they write their own APIs, but they also need, our backend for a lot of functions. So basically, when we decoupled it, the biggest thing there was always ensuring that our backend features, if there were a hard dependency on a front-end release, that we feature flag them appropriately so that we wouldn't kind of like break the cadence of any one team. What kind of testing do you use for the new platform? Exposed again. So we mostly do a lot of smoke testing and end-to-end testing, and we have probably like 14 different end-to-end environments at this point. The ops team has their own environment. We use a little bit of Modo to kind of test our CLI and some of our AWS code. But when it comes to like Terraform changes, we really haven't really found the right tool for that. I played a little bit with like Kitchen Terraform, things like that, and it just didn't like feel quite right. So what we do is we really just deploy to our kind of tech ops end-to-end environment and just make sure things stay green in Datadog, which we use for monitoring. How do you research when implementing new tech? Stack Overflow, Reddit, tech blogs. Hacker News is kind of like my go-to for like announcements of like kind of like shiny toys. If I want to go a little bit deeper, then I hit Stack Overflow. The AWS blog is pretty great. I subscribe to a couple of DevOps newsletters. DevOps Weekly is a really good one. And just kind of like what I'm really looking there initially is just kind of like high level like process improvements rather than like tech. I try to avoid getting too excited about new technology just because I think, I don't know, maybe I'm the only one, but you build a hello world, it's great, and then you kind of like push for it, and then you hit all the edge cases, and now you're waiting for PRs to fix this tool that you just moved everybody to. So, yeah. All right, I think that's it. Are we good to go? All right. Thank you all for coming.